I'm going to show you the easiest way to plot three lines, three linear functions on a graph representing the line of best fit or the average line of best fit for a relationship, and then the two outliers, one being the maximum line of best fit for the maximum gradient, and one the minimum line of best fit, that being for the minimum gradient. So here's my data table, and I want to plot average on the x-axis versus displacement on the y-axis. So I can select either of these to start the plotting of my graph. So I'm going to highlight the displacement data, go to insert, and I'm going to insert a scatter plot. Now this is just the data for the displacement, the points for the displacement. If I right click inside and I select the data, now I'm going to select my series here. I'm going to select the x and y values. I'm going to call this displacement versus time. And my x values are going to be the average time squared, so I highlight that and it comes up here, it reads those values. And I'm going to get rid of these y values, and I'm going to highlight the displacement, and there it is, displacement versus time. Click OK, and it's plotted those points from those columns. If I click on the points now and right click so I can add my trend line, I want a linear fit, which it's given me, line of best fit. I want to extend it backwards so it cuts the y-axis, so maybe 0.05, or maybe not 0.5, but we'll try 0.05. Maybe a bit more, maybe 0.08. And there we have it. Just wanted to cut it enough so we can make whatever significance there is in the y-intercept for our relationship. Okay, so there's my line of best fit. What I might do is I might display the equation on the chart, and I might also display the r² value. So there is my line of average line of best fit. Now, because we've got these uncertainties in our data, and this is the average of the three measurements of time which we then squared, what I'm going to do is I'm going to take the maximum value minus the minimum value of these three trials, or two of the three trials, the one that gives me the biggest range or the biggest error, and I'm going to divide it by 2 to get my uncertainty, which is plus or minus delta values. So I've done that here, and I've selected my values there. So next what I want to do is I want to draw my lines for the maximum and minimum gradients that fall within the uncertainty of my measurement. And to do that I need to draw error bars. Now the errors are in my x values, which in this particular case are the time, and we could probably put labels in the chart here so we know where we're going. So I'll primary horizontal, I'm going to call it just simply t squared. I'll fix that squared up in a moment, in seconds squared. Now to get the squared, you right click, highlight the two, right click, go to font, and then just make it a superscript. So there's a little t squared. Same for the seconds squared. Highlight it, right click, font, and I'm going to superscript it. So this is my time squared axis. I might just move that across here, and I might even make it a bit larger, so I'll go to font and I'll increase it to about 12. Okay. Let me just put a label in the y-axis while I'm at it. So the vertical axis represents the displacement. In fact, I might just write it as S, comma, meters. And I'll move that up here. I'll increase the font value. So I'll increase the font value, highlight it, double click on it, go to home, and give it a font of 12. Okay, so now I know where I'm traveling, what's what. So let's go ahead now and draw our lines or our error bars. Now keep in mind that I'm going to get potentially two types of error bars. The errors in the horizontal ones representing the errors in the time squared, and because the displacement in this particular case, there wasn't any trials that we made other than setting the actual distance, so we don't have to worry about the vertical error bars. So again, I'm going to double click inside the graph. I'm going to add my elements, come down here to error bars, and I'm going to click my more error bars option. Now as you can see, it's put some significant error bars here, both in the vertical and the horizontal directions. And if we have a look at the options here, these error bars represent a fixed value. So we've got percentage, standard deviation, standard error. We don't want any of these. We want to customize it. So we want to specify the uncertainty from the average. So I'm going to click specify, and a customs error bars box comes up. Now I want to select my values. So I want to take the average, and in the first place I want to add or produce a positive error value. So I want to add these values to my average. So let's do that now by selecting positive error values of my uncertainty, and you can see it's put that range in there. Now I want to do the same thing for my negative error value. So I want to take this average and subtract those values from it. So let's do that now. So once we've got that in place, I simply click OK, and now you can see I've got some error bars that look a little more what I should get. Let me get rid of these vertical ones, so I'll just highlight them and delete. So that gets rid of the vertical bars because my error is in the horizontal measurements. Now let me also grab this equation and pop it down here. I'll come back to that later. Okay, so we've got our error bars in place, and now we're going to plot our lines of best fit for the maximum gradient and the minimum gradient. Now to do this, we're just going to draw the lines in manually. So let me clean my space up a little bit here. I'm going to make my graph a bit larger just to spread those bars out a bit. There we go, so they're my error bars, and I'm going to come up here to draw. Sorry, not draw, let's go insert, and I'm going to use a straight line. So I'm going to draw a line from my lowest x value to my highest x value and y value. So from this point of the error on one error bar to the other. So I'll just draw it across like that. And while I'm at it, I might just give it a different color. So I might make this one. So this represents the minimum line of best fit. I might make it a bit thicker so we can clearly see it. There it is. And then of course I can extend it out beyond the y-axis. But the idea here is that it goes from this point to this point here. I'll do the same for my maximum line of gradient of best fit. So you can see this slope is smaller than the average slope, but I now want my maximum, so I'll do the same thing. So I'll go back to insert, and I'll grab a shape, and I'll take it from this error bar and across to that one there. And I might give that a color. I might make that one red, make it a bit thicker, and I might extend it beyond the Y. Now what I need here is I need my points to be at least to some degree in contact with every error bar. They have to be, the two lines which represent the extremes of the data have to be touching at least an error bar here. So you can see this one here, it's not touching the error bar. So what I might do is I might just extend this back a bit until it does touch the error bar, so that all of my points for my extremities are within those two lines. So again, I might just change it up a little bit like that. And when I look at all my points now, they have to be at least touching the error bar. So I'll call those my two lines of best fit. I think that's as good as I can get it. So there isn't any real precision to this. All you're doing is estimating those two lines such that most of your data sits somewhere in between those two lines with reasonable uncertainty. So the next thing I need to do is I need to find the slope of the maximum and the slope of the minimum lines of best fit. And then I want to compare them with the average line of best fit to see what my uncertainty is, how close I am, within what percentage all those points would lie. So what I'm going to do is I'm going to draw a text box. I'm going to put it in here. So I'm going to insert a text box. So I'll just grab a text box and I'll insert it in here, and I'll find my slopes within this text box. So the first thing I want to do is find the maximum. So that maximum line of best fit is actually the red one. So I'm going to find the slope of this line here. Now, to find the maximum, you know what the routine is. We take the rise and divide it by the run. So again, we are approximating this. So what's important here is the process. Alright, so here I have the data that I have calculated. So my maximum, based on the green line, there's my rise and there's my run, works out to 7.14. My minimum, which is based on the red line slope, is 6.09. So you can see that what should happen is my average should lie somewhere in between those, and sure enough it does. If we have a look at y equals 6.7588, so 6.7588 is somewhere in between those two, so I'm on the right path. Now my uncertainty in the gradient, so this is the uncertainty in the gradient, and again I take my maximum gradient, which is 7.14, my minimum gradient, which is 6.09, divide by 2, there it is there, and I get 0.0525. Now if I convert that to percentage uncertainty, I take my uncertainty divided by the average. Now the average is that value, should be that value there, so there's your average there. This is my uncertainty by 100, works out to about 1%, which is not a bad estimation, or accuracy in terms of how I've done the experiment. So there you have it. That's what you need to be able to do in your assignment, and hopefully I've given you enough here to help you achieve that.